Hello and welcome back. In the last video, you have understood about the JVM architecture. It's time to understand about one more important topic, which is static keyword. When it comes to static, we have three important components. We have static variable, we have static initialization block, and we have static method. How they are different from normal instance method, normal instance variable, which we also call it as fields, and normal static or normal non-static block or Java initialization block. How they are different from it. As we have seen in the last video of JVM architecture, static variable gets memory allocated on the heap area during the class loading itself. And if there is any static block, that also gets executed during the class loading itself. Fine. And static method, we shall understand about that also in this particular video. To start with, I would like to open my IDE, and you can see we have a normal Java program here. If I have to just print something here, system.out.println, I'll say here main method. JVM start the execution from the main method, and whatever you have written here, that will be executed. Let me just execute this program. If I have to execute this program, you can see main method, whatever we are printing here. In a class, we can also have the static variable. Let me make it static int is a type of A, and we can also have a block which is static. This is normal block, and to this block, if you just attach one keyword static, is referred as static block, or you can say static initialization block. Usually static initialization block is used to initialize this static variable. If you want to add some value, if you want to initialize any data to this variable, we use static initialization block, or you can say static block. However, if there are set of statements or any crucial code which you want to get executed the moment class is loaded on the JVM's ecosystem, then you can write that code within the static block. As you all know, we have understood static block also gets executed during the class loading. In this video also, we shall understand with respect to memory also. So I would like to just say here, maybe any value I would like to assign 4, and also would like to print system.out.println. I will just say here maybe static block. Fine. So now during the class loading itself, memory for static variable will be allocated, and if there is any static block, that also gets executed. Fine. Now JVM, in order to execute this program, in order to invoke main method and to execute this program, JVM will load this particular class on JVM's ecosystem. And as we have seen in the JVM architecture also, during the class loading, if there is any static variable, memory will be allocated on the heap area, and if there is any static block, that also will be executed. That means now if I have to run this program, you will see static block message first, then you will get the main method. During the class loading, this will be executed, and then JVM will invoke this method. Then the stack frame of this method will be created on the stack area, as we have seen in the methods concept, and this will be executed. If I have to execute this, you can see first you are getting the message static block, because when JVM will load this class into JVM's ecosystem for the execution, during that loading process itself, this will be executed, and memory for this also will be allocated. Fine. So let's understand this better by writing one program, all the components of a class. Whenever we have a class, let me write a class here, class alpha. We can have a variables which are static. I'll say here int is a type of A comma B. These are normal instance variables, properties, fields you can call. And to this variable, if you just attach one keyword static, now it is called as static variable. Fine. After which I'll have my normal variable into the type of maybe X comma Y, which is instance variables. What are instance variable? We have understood earlier also in this series. And now I will have a static block. I'll say static and maybe one block, and also I'll give some value here. I'll say 10, and I will say here B equals to 20. Great. And also I would like to just print one message, system.out.println. I will say here static block. I'll say static block, and after which I'll have a normal block. This is called as Java initialization block, Java instance block, Java block, non-static block, multiple names, just like this. And within this particular block, I would like to initialize the value for x equals to, maybe I'll say here 4, and I'll say y equals to 5. And I would like to also print one message, system.out.println. I will say here non-static block or Java block, any name you want you can give, non-static block. And then I'll have my constructor. In this particular example, I would like to include all the possible components which can be there within a class. I would like to just take this, go here, and maybe add, I'll say public alpha. Without public also you can write, it is an access specifier. That means everywhere you can invoke. That's the meaning of it. Anyway, going forward, we'll understand that also. And maybe I'll just say system.out.println. I'll say here alpha constructor. As you all know, constructor gets executed during the object creation. When you create the instance of alpha class, object of alpha class, during that time this part will be executed. About constructor we have also understood in this particular series, in this particular playlist. After which I'll have methods. I'll have a method, maybe I'll say here void display. All right, and within this I'll say system.out.println. I'll say here display method of alpha, great. And I would also like to print some values here, system.out.println. I would like to just print, or maybe this much for now, it's sufficient. Okay, I'll talk it later. Now like the display, I would like to have one more method called as the show method, and this method I'll just add one thing called as static. That means it is now static method. It is a normal method, normal instance method, and this is a static method. Great. So I'll say here display, or maybe I'll say here static method of alpha. So we can have a static variables, normal instance variable. We can have a static block, normal block. We can have a constructor. We can have multiple constructor. That's a different case. We can have a normal method and the static method in a class. Great. Now I would like to just create the instance of that class. I'll say here alpha type, maybe I'll say here alpha type A equals to new alpha. Great. I have created the instance of alpha. Now I'll say here, please see very carefully, a dot display. Great. Or only this much I would like to create. I'm not going to invoke any of the methods. I have just created the instance. Okay, I would like to save this, and I want you to understand better. I would like to just go here, run as the Java application, and you can see main method. From here the execution is beginning, and I've asked my JVM, please create the instance of alpha, create the object of alpha. In order to create the object of alpha class, JVM will load this alpha class in its ecosystem. Alpha class will get loaded into JVM, and during the class loading, if there are any static variables, memory will be allocated, and if there is any static block, that also will be executed. This will be executed first itself, and when you're creating the instance, that time the remaining part will be executed. What do you mean by that? Let me just take this program here. I would like to just take this program, and I would like to open my board work here. I would like to just scroll a bit, and let me just add this particular example here. I have added it, and it's fine, looking good. And now I would like to just demonstrate what exactly is happening here. So let me just get here. Let me consider the heap area, which is one of the most important area in the JVM runtime areas, which we have understood earlier in the concept of methods, instance variable, local variable, and also in the concept of JVM architecture. About the heap area, we have understood very well in our previous videos. I request you to watch it. Fine. Now guys, when this class gets loaded, during that time on your heap area, memory for A will be allocated. JVM will allocate the default value. Default value for integer is 0, double 0.0. If it is string, it is a null. Since it is int, the default value will be 0. And memory for B also will be allocated. It is 0. We have understood that in the last video theoretically. Now practically we are seeing it. Great. And if there is any static block, that also gets executed during the class loading itself. When this class is getting loaded into JVM that time. Now inside the A you are assigning 10. Inside the B you are assigning 20. And whatever message you are printing on your console, on your console, that message will be printed. Static block. After the main method, it is static block. And later in the main method, you are creating the instance of alpha class. You have told new alpha. Since you have told new alpha, now object has to get created. And on your heap area, one object will be created. Every object will have some address. I'll assume the address of this object is 1000. And you're creating during the object creation, if there are any instance variable, object variable, fields, memory will be allocated inside this. About this in detail earlier in this playlist we have understood. You can refer that also if there is any ambiguity. Memory for X will be allocated inside the object, inside the instance, and default value is 0 because it is integer. And memory for Y also will be allocated. Great. Default value is 0 because it is also integer. This is the instance variable directly inside the class. Okay. And now you're creating the object. During the object creation, you're invoking the constructor. When you invoke the constructor, from here, control would go to constructor. Before the body of constructor, actually it is the non-static block which gets executed, a normal Java block which gets executed. So far in this entire playlist, we have not seen about a normal instance block. For the first time we are seeing, but for the first time only, please do understand, when you create the object, which you are already aware that constructor will be invoked. When you invoke the constructor, before the actual body, actual implementation of the constructor, it is the non-static block, a normal Java block will be executed. And now what is the value inside the X? It is 4. Inside the Y it is 5. And you will get the message here, non-static block. Non-static block. After executing this, it will come back to constructor from where it has gone here, and the remaining body of the constructor will be executed. Then you will get the message alpha constructor. Making sense? And this will be our execution flow right now. We are not invoking these methods, we will see here, but this is how the execution which is happening here. Let me go back to the program here, and I would like to just execute this. If I have to execute this here, main method, because main method the execution is beginning, it is static block, then non-static block. When you created the instance of alpha, control came to this constructor. Okay. And before executing the actual body of the constructor, from here non-static block gets executed. Later the body of constructor will be executed. So normal Java block will be executed when we create the object before the body of constructor, right? Whereas the static block, this will be executed during the class loading itself. When the class is getting loaded into JVM, that instance itself, this will be executed. Now I would like to just go here and say a dot display. I'm invoking display. And if you want, static method we have, which is show. This static method can be invoked with the reference variable also if you want, no problem. I'll say here dot show. There is no problem, you can invoke. However, you can also invoke this directly with the class name also, because static components are always object independent. They are not depending on the object. Why? The memory for this is getting allocated even if you don't create the object. When the class is getting loaded, that time itself. And this will be executed during the class loading itself, right? Whereas normal things are there. No, this memory for this instance variable will be given. The life for this instance variable will be given only if you create object. And you can invoke constructor will be executed during the object creation. That means object should be created. And this method you can invoke with the reference variable only if you create the object. All of them are object dependent. All of them will be executed only if you create the object. And static is object independent. I can say here dot show. That is, static method can be invoked directly with the class name is what I'm trying to say. With the reference variable also you can invoke, but they are not needed to be invoked with the reference. Directly the class name also you can invoke. And I would like to just execute right now. You can see here main method, which is static block, non-static block, constructor, the display method of alpha, because first I'm invoking this. So methods will be like who you invoke first, that will be executed. Then you're getting the static method. If you invoke this will be executed. But if you invoke this, whichever method you invoke first, whether it is a static or non-static, that will be executed, because methods will be executed only if you invoke. Constructor will be executed only if you create the object. Only thing which gets executed only if you don't do anything is main method and static block. Because main method, JVM will initiate the execution, JVM will start the execution of your Java program from the main method, automatically that will be executed. And if there are any static initialization block, if there are any static block, automatically when this class gets loaded into JVM's ecosystem, during that time this will be executed. One more interesting part you need to understand here. I'll create the instance of alpha once again. One more time I'm creating the instance of alpha. Two objects are there. I want you to understand this very carefully. If I have to just run this, I would like to, okay, the reference variable is same. I would like to go with A1 and let me just execute it. If I have to invoke this, you can see guys, static block message you're getting only once. Remaining methods you're getting multiple times. You're not getting the static block message once again. What exactly is happening here? Please understand with respect to memory really well here. I would like to go back here. And one more time I have created object, right? I have invoked some methods here. I have created the object one more time. I've created the reference A1 equals to new alpha. When you created the instance, this class is already loaded. So one more time memory for static variable will not be allocated. Only once it is allocated, that's over. Static block only once during the class loading. Now one more time you are creating the object here. So one more object will be created. Address of the object will be given. And if there are any instance variables, memory will be allocated. Default value is 0. Why? The default value is 0. Again, before executing the body, non-static block gets executed, 4, 5, and the actual constructor body will be executed. After executing this will be executed once again. What I'm trying to say is, instance variable memory will be allocated every time you create the object. What do you mean by that? If I create 100 objects, 100 times memory for X and Y will be allocated inside those objects, inside those instance. Instance means object, object means instance. Inside the object, memory for X and Y will be allocated how much ever objects you create. Right now I have created 2 objects, memory for X and Y, 2 times inside those objects will be allocated. 2 times whenever you create the object, constructor will be executed. And as I have told already, before executing the actual body of constructor, the non-static block will be executed. Then again the body of this also will be executed every time you create the object. Wherein static variable, first time when the class is getting loaded, only that time memory will be allocated only once. Alright. And whatever code you write inside the static block, that also gets executed only once. At the beginning, when the class is getting loaded, executed, finish. Only once it will be executed. Hence, for the static variables, we also referred as class variable. Whenever we have a common copy of data, if the data is common copy of data for all the objects of a class, some data is there which is common for all the objects of a class, then we go with the static variable, because memory will be allocated once and whatever value you assign here, it is going to remain same throughout the execution. Wherein, whenever you create the object, memory will be allocated inside this object. And for object to object, the value of X and Y might differ. Maybe second time in the constructor you are passing the value, that will be given. Third time when you create the object, through the constructor you are passing one more value, again that will be differing, right? So I hope you have also watched the video of instance variable, constructors. I am keeping in mind that those who are watching this entire video is already aware of what we have seen earlier. Instance variable, local variable, reference variable, constructor execution you have seen. You might have also seen about the JVM architecture. Then this video to follow up, it will be very easy. If not, please do watch that and then continue watching here. Fine. The conclusion here is, as we have seen in the last video theoretically, that whenever a class is getting loaded, during that time, if there is any static variable, memory will be allocated on the heap area only one time. Generally one copy of heap, on the heap area. If there is a static block, that will be executed. After which, if there is an instance variable, name itself instance variable, object variable. Whenever you create the object, inside that object, memory for instance variable will be allocated. If you create maybe 100 objects 100 times, 200 objects, memory for x and y will be allocated for 200 times because it is instance variable. And they will be getting the life only if you create the object. If you don't create object of alpha, then there is no life for x and y. There is no life. Even if you don't create the object of alpha, there is a life for a and b because they are static. When the class is getting loaded, that time memory allocated, not on object creation. X and y memory will be allocated only if you create the object. If you create the object, memory will be allocated. One object will be created inside this memory. But for a and b, it is static. Object creation is not the condition. When JVM is loading this class into its ecosystem, memory will be allocated. They are object independent. They get life when the class is loaded. X and y will get a life when you create the object. Fine. And that is the reason static variables you cannot use inside non-static method. What do you mean by that? Because this method you can invoke only if you create the object. If you don't create the object, you cannot invoke this method. There is no life for this method. But whether you create the object of the class, if you don't create the object of the class, doesn't matter. If there is any static variables, memory for that will be allocated. The life for that will be given. They are object independent. And I mean to say, this can be used inside the static. I have told reverse. Let me just correct it. You can use the static variable inside the non-static method. There is no problem here. Okay. I can just use and show you. I would like to print the value which is there inside this a, which is a static variable. You can see, guys. And I would like to print the b. And normal xy also you can print. There is no problem. Let me just print. So inside a normal method, you can have, inside a normal method, you can also have, let me just add it. I'll say here y. Inside a normal method, you can have memory for a and b, x and y. That means you can use any of, you can access any of these variables, whether it is static or non-static. However, inside a static method, you cannot have a non-static variable. What do you mean by that? This is a static method. Okay. I cannot access x and y here at any cost. Why I cannot access? Because x and y are normal variables. Why so? This instance variable, normal variable, gets life, gets memory only if you create the object. Suppose if you don't create the object of alpha, then there is no memory for these variables, because inside this object of alpha only memory for this will be allocated. And if you have not created the object of alpha, then there is no life for this. However, static components can be invoked without the life. Directly the class name also you can invoke. What do you mean by that? I would like to just go here. I'll do one thing. I would like to comment this. Okay. I will just say here alpha dot show method. You can see here inside this entire class, am I creating the object of alpha? No, I'm just using the reference. I'm just calling the show method. That's it. And if I have to execute this program, kindly see here, main method static block and static method of alpha. That means static components, memory for this also got allocated. This also is getting executed and this is also getting executed. So static components of a class are not object dependent. You can invoke them directly with the class name. You need not to create the object to invoke that. When the class is getting loaded, memory for this will be allocated. Whatever code is there, that will be executed, and with the help of class name, you're invoking this method. This is getting invoked. Now, if you allow using the normal variable inside the static method, then it will be against the rule it is working currently. That means right now, are you creating the object of alpha anywhere? You are not creating the object of alpha anywhere. If you are not creating your object of alpha, that means there is no life for x and y. Anywhere life is not there for x and y. If there is no life for x and y, then is there any sense to use that variable if there is no life? Because x and y are normal instance method. They get life only if you create the object. You have created the object here, they got the life. If you don't create the object, they will not get any life. I hope you are understanding what I am trying to say here. Fine. So just to conclude, Static variable gets memory only once when the class is getting loaded on your heap area. And if there is a static block, that will get executed. Remaining part depends. Normal method you can invoke only if you create the object. When you create the object, only then memory for instance variable will be allocated. If I have created object 1000 times, inside those objects in your heap area, 1000 times memory for x and y will be allocated. But for static, only once, first time when the class is getting loaded, memory is allocated. Finish. And same copy of data will be used throughout, and so we also call it as a class variable. They are not dependent on object. Only once memory will be allocated during the class loading, and this will be allocated, executed during the class loading. Normal Java block will be executed when we create the object. Before executing the body of constructor, control will come here. It will execute this non-static block. Then control go back and execute the actual body of constructor. So when you create the object, before executing the constructor body, what gets executed? A normal Java block. Fine. And then normal method, if you want to invoke, you have to create the object of alpha or whichever class, and then you can invoke. Wherein static methods can be invoked directly with the class name. Static methods can be invoked directly with the class name. Fine. Summary here. Static variables memory will be allocated only once for the first time at the time of class loading on your heap area. Second point, if there is a static block, that also gets executed during the class loading itself for the first time. Then static methods can be invoked directly with the class name itself. This is the conclusion of static variable, static method and static block. I hope you have understood, and to get a better clarity, I would request you to watch the previous videos of this series on the concept of methods, instance variables, JVM architecture. You will get better clarity on this video itself. Thank you so much for joining me in this video. We shall meet again in the next video.